Hello and Assalamualaikum. We are group 6 and we are going to present about negative level D-Latch. This is our team role. The first one is Muhammad Ashraf as a project leader, Muhammad Shafiq IZZAT as component design engineer, Muiz AKRAM as mass engineer, Muhammad NASHRUL IKRAM as IC design engineer, and me myself, Muhammad FIRHAD as a logic engineer. So this is our introduction. The startup company manager proposed the engineer to complete a project to construct a library cell for a latches, which refers to an integrated circuit design house. There are several roles for the engineer in the team to set up and the project executed within the timeline as a plan. On the other hand, the project must achieve the requirement with quality or service since the market is very competitive. As a general, D-Latch is an electronic device that can store a bit of information, which the functionality is used to capture or latch the logic gates present on the data line when the input clock is high. If the data on the D line changes state while the clock path is high, then the output Q follows the input D. When the clock input falls to the logic 0, the last state of the D input is trapped and held in the latch. The project focuses on the negative level D-Latch. So this is the project planning. First, we divide the task and then divide the specification, and then doing the schematic design. After that, schematic simulation, design layout, characterize, propagation delay, design rule check, layout via schematic, post layout simulation, final testing, and project presentation. So this is the Gantt chart. So the first day is to divide the task, and second until fourth day is design a specification. Day 5 until day 6 is to schematic design. Day 7 and 8 to schematic solution. Day 9 until day 11 to design the layout. Okay, then day 11 until 13 is to characterize propagation delay. Day 14 until 15 is to design a check rule. Day 16 and 17 to layout versus schematic. Day 18 and 19 to post layout simulation. Day 20 is final testing, and the last day, which is day 21, to projects presentation. That's all from me. Thank you.
Assalamualaikum, my name is Muhammad IKRAM. I would like to present about project flow. We choose analyze IC design. Let we see the flow. First, design specification, then schematic flow, and then physical flow. For design specification, it has two: specification and component. Specification is a set of requirements which should be met and hold true across all possible operating requirements. For the component, we choose the characterized of negative level D-Latch. For schematic flow, it has skirt level schematic entry, skirt simulation, and optimization. For the skirt level schematic entry, drawing skirt schematic and show a component level view of your electronic design. For skirt simulation and optimization, analyze using various software algorithms which predict and verify the behavior and performance of the circuit. For the physical flow, it has design rule check, layout versus schematic, post layout simulation, propagation delay measurement. For design rule check, we verify as to whether a specific design meets the constraint imposed by the process of technology. For layout versus schematic, we compare the extracted netlist from the layout to the original schematic. For post layout simulation, we involve extraction of physical information from the root board. And propagation delay measurement, we calculate the propagation delay of the circuit.
Assalamualaikum. My name is AKRAM Muhammad SAPIE. This is the schematic of the negative level D-Latch, which has two NOR gate, two AND gate, and two inverter gate. This is the output waveform of the negative level D-Latch, This is the calculation for the TP low to high, which get from the input D and output Q bar. We using D and Q bar because of the value of output changes based on the value input. This is for the calculation of VT high to low, which is using input D and output Q bar. So we are using output Q bar because of the changes value based on the value T. This is calculation delay propagation for schematic. Thank you.
Assalamualaikum and hi, my name is Muhammad IZZAT bin ABDUL. So in this part, I'm going to explain about the delay after the layout. So first, we need to design the layout in the layout editor, and then we need to go to utilities and check the DRC and make sure there is no error. Next is to check whether the layout design match the schematic or not. First, we need to click the build connection and then click on set node modes and followed by layout versus schematic. Okay. After that, we go to utilities, technology, OpenCell library, and then extraction. In this part, we need to change the value of from Atto to Femto, and then for the simulation part, we use the previous setting. And next, for propagation delay measurement, we compare the value of D and value of Q bar. Okay, for value of TPHL, we got 246.7097 PS, while for value of TPLH, we got 108.77545 PS. And then we can calculate the propagation delay. Actually, we got 177.742575 PS.
Assalamualaikum, my name is Muhammad bin SALMI, and here I will present the obstacle that we faced during the making of our project. The first obstacle that we face is resource finding. Physical book is hard to find in local library that match our topic of interest, thus it has stunned our progress greatly. Next, the second obstacle is time management. Coincidentally, time allocated to finish the project is the same as the time allocated to prepare for a final year project. Thus, each team member has been busy with their own work. And lastly, the third obstacle is software limitation. The software that we use is limited, thus the software doesn't allow us to save the layout that we built locally. This meant that we need to build the layout each time we want to test or measure the result. After that, for the conclusion, during calculating the propagation delay for the pre-layout and post-layout, we find that pre-layout simulation has lower propagation delay compared to post-layout simulation. Thus, we can conclude that pre-layout simulation has greater efficiency compared to post-layout, since pre-layout simulation is done by computer, thus it has higher efficiency, whereas the post-layout simulation is done by human, resulting in lower efficiency in the circuit. Also, in this project, we learn time management, where timeline is set to make sure the project is in progress. Work distribution, where work is distributed among each team member to make sure each person has responsibility. Teamwork, where each team member work together to finish their tasks and provide helping hand to others. And lastly, IC design, where team members learn about latches and how it works with the addition of the component needed to build the such latches. And that's all from us. Thank you.